Hey everyone, you guys ready to roll? All right, hello everyone. My name is Bryant. I'm in the product planning and marketing team here at AMI. Just very briefly about who AMI is. AMI is a foundational technology company. We've been providing firmware or platform firmware to the industry for years. We really are at the center of the overall compute ecosystem. You'll find our solutions across multiple manufacturers' platforms, across multiple hardware architectures. You'll find us across multiple market segments, from client and server to hyperscaler, all the way to the embedded market segments. Now, we're a proud sponsor of OCP and quite active in the open system firmware, hardware management, in addition to the Calyptra project working groups. Just yesterday, we announced our participation in OCP SAFE. Now, this is a broad initiative to really enhance the overall security of hardware and firmware and the overall compute ecosystem supply chain. So today, we want to talk about firmware management for tomorrow's data centers. And as the data center becomes increasingly diverse, management of firmware in this broad ecosystem of hardware and hardware vendors is going to become increasingly more complex. And it has real ramifications not only on your operational efficiency, but it also has an impact to your security posture as well. So today, let's explore how do we navigate this complex firmware landscape, and then how do solutions such as common source firmware really simplify your overall operations, improve your security, while addressing the compatibility issues that exist in this multi-vendor environment. All right, so as we think about hardware, tomorrow's data center, I mean, OCP is at the nexus here, right? No one's done more to transform how we think about hardware and the data center. They've been instrumental in driving standardization, innovation, and collaboration by bringing the industry together to really think about how do we design, develop, deploy, and manage this hardware. So just a few notable examples here. So through the Rack and Power and the server project groups, they brought together industry leaders across hardware technology, manufacturing, CSPs, and hyperscalers to collaborate on how do we define and design more scalable and efficient hardware. Through initiatives such as DC-MHS for modular hardware system, DC-SEM, they've driven this whole notion of a more flexible and modular hardware, which gives the organizations the ability now to combine and build custom solutions that now scale in their unique environments. They have been really the driving force behind this shift, if you will, to more of an ODM direct purchase model, which gives people ability to have access to the latest and greatest hardware technology at a much lower price point as well. And they're also at the forefront of all the emerging standard technologies, such as the Open Accelerator Interface, for an example. Now, if you put all this together here, right, the way we like to think about it is OCP is really democratizing hardware, if you will, to make it available for the masses. Organizations now have the ability to have access to advanced hardware without vendor lock-in, right? And they do this by creating this environment, if you will, of competition, of collaboration, and innovation. Now, as they have moved the industry forward, right, there's still challenges that we need to address. Namely, how do you deal with the firmware compatibility issues that exist in a multi-vendor environment? I mean, how do you create a more cohesive solution that's going to ensure consistency in firmware behavior across your multiple platforms? So let's start with the hyperscaler here, because they really do give us the blueprint of how we need to think about and address this problem. Now, no one has epitomized this move more to the direct ODM purchase than the hyperscaler. I mean, historically, they did buy directly from the OEMs, but that model's largely been disbanded. They now buy custom hardware directly from the ODM, which gives them the ability to design and deploy hardware that perfectly aligns with their operational needs without having to deal with the overhead that standardization, if you will, brings from the OEM. Now, this has given them tremendous benefits. So first, they have access to the latest and greatest hardware technology at a reduced price point. They now control the life cycle of their hardware. So that means that they now can customize it for optimal performance, right? And then they're not locked into any one single vendor. Now, the other pivotal thing that they did was they took control of their firmware just like their hardware. So they created common firmware across all their platforms and their vendors, which now allowed them to have more consistency, control, and to drive overall operational efficiency. So let's talk about platform firmware in the context of a compute system, if you will. So a compute platform is defined as really this combination of hardware and firmware components that enable you to do three core things. First, power up your system. Second, make sure it stays operational during this life cycle. And third, make sure that it runs secure. So what I'm showing here are various open source frameworks that are really responsible for these functions and these operations. So if you look at firmware, for example, or BIOS firmware, which is responsible for the boot process, here we got Linux Core, Linux Boot, Tiana Core. It could be Core Boot, U-Boot, others. Its primary responsibility is to make sure that your computer turns on efficiently and correctly. Now, when you look at the BMC component and its firmware, it plays a vital role in making sure that your hardware is secure or safe and healthy across its entire life cycle. So here we show OpenBMC, which is the primary framework, and it's really responsible for controlling and monitoring your things such as your power supply, your temperature, and your fans. And then lastly, we show hardware root of trust. Now, this is responsible for making sure that all of your platform firmware is secure. So this is not just for your BIOS and your BMC. This is also your device level firmware. It could be RAID cards, NIC cards, power supplies. It also is silicon as well through the Calyptra initiative as well. And it does this by making sure that your firmware has not been modified or tampered with in any way during the power up process and the runtime. Now, the key message I want to leave you with this slide is, depending on the manufacturer that you purchase from, they're free to choose any of these open source frameworks, any combination of, even within a given vendor, depending on the generations, you're going to have different versions of firmware. So let's talk about what happens when you get into a multi-vendor environment. Okay, so we want to be in a multi-vendor environment. We talked about this at the very beginning. This is what core tenet of what OCP is trying to achieve here. So in this example, let's look at three separate vendors, and let's just use OpenBMC as a use case. All right, well, you may think, I mean, OpenBMC is the standard framework, so there should be no issues. Well, OpenBMC is extremely fragmented. Depending on what hardware technology you use, Intel, AMD, Ampere, NVIDIA, they all use different versions of OpenBMC. Now, to complicate things, since it's based on Linux, they all have different combinations or different kernels, which means there's different combinations and permutations there. And to make it even more complicated, there's no one repo. Each of these have their own repo, and it could be private and public depending on whether a feature's been embargoed or not as well, okay? So what are the potential problems that may exist here? Well, the first is you may have inconsistency in sort of these standard interfaces. Now, Redfish is a prime example. Depending on the vendor, the firmware, you're likely to get a different response back depending on who you're querying for information. And we'll show a use case here, an example of that in a moment here. The other thing is firmware. All these vendors have their own update packages, their own procedures and processes, so you can no longer streamline the firmware update. You're going to have to deal with each vendor separately, which is going to make your overall process or make your operations more inefficient, okay? We talked about this. There's no cohesiveness across the different manufacturers in terms of firmware. There's no standardization at all, which then means that you're more than likely to say, hey, I'm just going to choose one vendor because I don't want to deal with these complications of having multiple firmware versions. But that undermines the entire premise of what OCP is trying to achieve here. So let's go through a use case here where you have a system admin that wants to send a Redfish command down to query for certain chassis information. So here, vendor A, you get a incorrect response or a broken response. More than likely, the data is incorrect, there's a missing element, system couldn't interpret it, so you have no visibility in what's going on there. Vendor B, on the other hand, it returns a correct response, right? It's compliant with the Redfish specification, right? It sends back usable standardized data for the system admin to interpret. Vendor C potentially is going to send back an incomplete response. So maybe it's not fully compliant with Redfish. Maybe there's inconsistency in the data. The challenge here is that you can't really interpret the information. So now just imagine how this problem gets magnified when you scale this out to hundreds and thousands and more vendors. It becomes very complex and exponentially difficult to manage. Oh, sorry. All right, so hyperscalers learned a while ago taking control or having common firmware gives them a lot of benefits, right? They now, if they unify their code across all of their platforms and vendors, they have common firmware across BIOS, BMC, and hardware root of trust. This now lets them have a more consistent response and behavior regardless of the vendor or the platform that they're using. They now can optimize their firmware for optimal performance. They can actually scale or streamline their operations for management at scale now because of that. Now, the other benefit is what we call customization with commonality. And what we mean by that is even though they're building off of common source, right, they still can modify a platform or, for a given use case without having to rebuild from scratch. So now they can work with any of their particular ODMs, customize the platform, integrate it into their fleet of servers, and be assured that the overall behavior of the firmware and the consistency remains the same regardless of what underlying hardware and customizations they may have done. Lifecycle, they now control the firmware lifecycle. So now they control when they do their firmware updates, when do they do the security updates, the patches, the fixes, and so forth. Now, they don't have to rely on a vendor, which you can imagine if there's a vulnerability that exists, you want to patch that right away. You don't want to have any exposure. If you have to rely on a vendor, you may get delayed in updating your firmware to address that issue as well, okay? And then lastly, as we talked about, they own the firmware, the consistency across all their platforms. They now can use any vendor that they want. They can go back and forth between multiple ODMs, and you can imagine the benefits this gives them from a supply chain perspective as well. All right, so as we get beyond the hyperscaler, so let's just say the next wave CSPs, the neo clouds and others, we see too that they are embracing common source firmware because of the benefits that we talked about. They want to maintain control and consistency of their diverse hardware. Now the other critical thing is that to ensure this long-term stability of their platforms, this is where firmware platform lifecycle becomes critical. So what I'm trying to show here is that your journey begins at the deployment phase. Here, you will have customized your firmware, ported it to a given platform. Hopefully, you use common source firmware, so now you can then modify or adapt the platform without having to rebuild, and then you can deploy it. Now, when you get into the maintenance phase, standard or extended maintenance phase, you still need to have this ongoing stream of firmware updates. You've got bug fixes. You want to stay consistent with the latest industry interfaces. Most certainly, you want to make sure that you keep up with the security patches because that does not go away across the life cycle. Putting all this together, this will give you a seamless, up-to-date firmware experience and also help you streamline and improve your operational efficiency. Now, as you grow and scale and firmware becomes more complex, you may decide that, hey, I don't want to really be responsible for the platform firmware lifecycle. I don't want to have to build out these huge teams like the hyperscalers do to be able to manage that. And that's where a partner like AMI has built several capabilities to help you have that seamless firmware update experience. So the first is what we call dynamic firmware. This is modular firmware that can be adapted to any hardware architecture. This is the basis of your common firmware. This is what you're going to build across platforms, across BIOS and BMC and hardware root of trust. Now, the next capability we have is an orchestration service called Meridian. Very much like platform as a service, infrastructure as a service. Think about this as firmware as a service. This is going to let you customize your firmware for a given platform, adapt it, deploy it. It will generate all the test cases. It will generate the SBOM and the manifest. It has a whole suite of security tools in terms of vulnerability management, in addition to remote attestation as well, okay? Now, if you want a more sort of complete data center management capability, this is where DCM comes into place. Here, you can optimize for power, thermal efficiency, server utilization, while at the same time having an automated and centralized capability for firmware lifecycle management in terms of configuring, operating, pushing, and maintaining that firmware as well. Okay? All right, so 3 things I'd like you to leave here with. First, leverage common source firmware for scalability. It's going to simplify your security in addition to improving your operational efficiency. Leverage open source. You can now customize that for any given platform in your use case while leveraging all the community-driven innovation. And then lastly, if you want to partner for firmware, choose someone that's got experience with firmware lifecycle management and also has very deep relationships with all the hardware technology silicon providers in addition to the ODMs. Come visit us at 827. Thank you very much for your time.